Welcome everyone, and thank you for joining us on today's webinar, Energy Management, Finding Hidden Efficiency Opportunities. I'm Allison Sterling, Marketing Manager at Emerson Micromotion, and I'm pleased to welcome you to the Emerson Flow Expert webinar series. Before we begin today, I'd like to take a moment to acquaint you with your webinar environment. On your screen, you should see a presentation window to the left side, a Q&A chat window in the upper right-hand corner, media player controls, and a resource box with related content that you can view and download during the event. And you can also resize, move, or minimize any of these windows during the event to fit your viewing preferences. You'll also notice at the bottom of the display you should have a row of icons that give you added capabilities. You can share this webinar via social media channels or use the Contact Us button to request a visit or a response from any of our Flow experts. Throughout our presentation today, we encourage you to interact with our speakers by typing in questions and comments using the chat panel. We will be answering questions throughout the event. We are also recording today's webinar, and we will make this link available to you via email 24 hours post-event. On today's webinar, we are lucky enough to have joining us both Tanya Wyatt, the Global Chemical Industry Marketing Manager for Micromotion, as well as Julie Valentine, the Global Refining Industry Marketing Manager for Emerson Flow. Tanya Wyatt has been with Emerson for over 15 years, working closely with customers across multiple industries around the world to help improve their flow measurement and to improve process efficiency. Tanya has authored and presented numerous flow measurement papers at industry events. Before joining Emerson, Tanya spent 3 years working in a chemical plant doing R&D. Julie Valentine has more than 20 years of experience working closely with Emerson's refining customers to identify flow measurement problems and help them optimize their operations. A co-inventor for 2 patents, Julie has also authored several technical papers on flow technology for the refining industry. Before joining Emerson, Julie spent 8 years in the technical services group for UOP, where she was involved in the commissioning, startup, and troubleshooting for UOP process units around the world. Welcome, Tanya and Julie.
Thank you. Thank you, Allison. So I'm Tanya, and I'm going to go ahead and get started for us. And thank you all for attending today. We know that you're really busy, so we appreciate you taking time out of your schedules to be here. During this webinar, we're going to discuss the components of a good energy management information system. So including monitoring, using that information to establish appropriate reduction targets, and reporting. We'll then get into a little bit more detail on the monitoring side of energy management and talk about combustion control and how improvements there can help you not only to reduce your energy usage, but also to reduce emissions. And then we'll talk about how environmental greenhouse gas reporting can tie in as well. We'll discuss a bit about flow measurement for your steam, managing the steam flow, and I'll include a story about a petrochemical company that was able to improve their overall steam efficiency by 3% and save over 200,000 euros in the process. Finally, we'll wrap up the webinar and answer as many questions as we can get to. So with that, let's go ahead and get started. So whether you're working in a refinery and have to meet certain energy intensity index numbers or in a chemical or petrochemical facility, you probably have some pretty aggressive energy reduction goals that you're trying to meet. If you meet or exceed that goal, you can definitely look like a hero, but if you miss those targets, you're likely to bear the brunt of the blame. We talked to a lot of customers and found that there are really 3 things that can stand in the way of meeting these targets. And we're going to address all of those today. So the first is not having visibility into the process, or not knowing where energy is being used and not being able to see where there are some inefficiencies in your system. The second area of frustration is really around variability of the process that forces you to operate more conservatively than you should, just so that you can meet quality and safety requirements. So having a better understanding of the variability would definitely allow you to operate closer to the ideal point and reduce your overall energy usage. And finally, everyone's fighting for budget money these days, so every project has to be able to show good payback information and really prove to be viable. So we'll attempt to address each of these areas today to help you justify investments to ultimately meet your energy reduction goals. So in this first section, I just want you to ask yourself, like, what if you could gain greater visibility into your plant's energy consumption and loss? Well, who wouldn't want that? Of course, you could verify your energy losses, and then you could take that information that you have about your energy system, and you can set targets and really make a difference in your daily energy usage. Most people do have some sort of energy management information system, but the problem in a lot of cases is that it's really acting as a reporting system with energy consumption based on accounting allocations. So there really isn't any knowledge about who is using the energy, just theoretical calculations that are behind the process. It also gives you information after the fact. So it's like trying to drive while looking through the rearview mirror, and it doesn't tell why the consumption has changed. It's really difficult to figure out root causes of problems when so much measurement is missing. There are a lot of technologies available to cost-effectively expand energy measurement, and even simply 1 or 2% energy improvement, if you can get that, can mean significant financial benefits for your company. For example, a 2% reduction in energy usage in a refinery is worth as much as $2.6 million a year for a 250,000 barrel a day refinery with fuel costs assumed to be $3 per million BTU. You've probably all heard the expression that you can't improve what you don't measure, and this is absolutely true for energy management. If you don't have instruments measuring energy usage, it's really difficult to find the areas for improvement. Wireless HART enables energy management that can be cost-effectively installed anywhere. Emerson has a breadth of process measurements and control for energy, including the world's largest portfolio of measurement and control devices and acoustic monitoring of steam traps and pressure relief valves. In addition, we have a lot of energy expertise. We have consultants that know the best practices for optimizing energy with measurements and control, and we offer consulting services for energy audits. For additional information, there's a link in your resource center to request a Powerhouse Energy Opportunity Survey. If you qualify for that, an Emerson Industrial Energy Consultant will help you develop a customized plan to reduce energy usage throughout your plant. Energy Advisor is a real-time energy management information system, or EMIS, that Emerson has produced that automates the process of mapping and managing energy consumption across a site as it is being consumed. Real-time alerts, dashboards, and emails notify decision makers when energy consumption is above expected, and not only that, but it shows actions that can be taken to drive down energy costs. It helps you know what energy consumption should be for a piece of equipment and track energy consumption versus those expectations. It automatically alerts you to overconsumption events and tracks the reasons for those events. The real-time dashboard of your energy performance helps demonstrate your energy improvements over time. It has some rigorous models built in that help simplify your management. Implementing such a system is likely to uncover plenty of energy savings opportunities. If you want more information about the Energy Advisor, we aren't going to talk in any more detail about it today, but there is a link to download the product data sheet in the resources panel. Energy management is an important part of your business, and there are opportunities really throughout your plant to save energy. Here's a list of some of the areas that may be available for energy improvements. It's really not uncommon to be able to see 5 to 10% energy savings by implementing an effective energy management system. Each of these areas can be addressed with the Energy Advisor, like I mentioned, and with our energy opportunity surveys. We're going to specifically discuss combustion control as it relates to your boilers and furnaces in just a minute. But first, I'm going to have a little audience interaction and ask you a question. We'd like to get some input from you. What aspect of energy management do you struggle with most? So we talked about visibility, variability, or viability. If any of those resonate with you, go ahead and pick one of them and submit your answer. Obviously, there are no right or wrong answers. We're just kind of looking for what people think in terms of the biggest challenge for implementing or for meeting those energy reduction goals. Looks like we have quite a few answers coming in. I'll give you just another second or two here to answer. So far it looks like a lot of people struggle almost equally with visibility and viability. Go ahead and look at these answers here. Sorry, I went one screen too far. So it looks like visibility definitely is a big problem for a lot of people, and so we'll talk about that with some of our instrumentation. And I'm going to turn it over to Julie now to talk a little bit about the variability piece.
Okay, thanks, Tanya. Okay, so what if you could reduce process variability and run your operations closer to the optimum point? In this section, we're going to talk about how to achieve that and to push your process constraints to operate your combustion more efficiently. We'll also talk about how fuel measurement can be used to help you comply with greenhouse gas requirements and minimizing the burden of proving and documenting that the accuracy of the measurement is correct for reporting purposes. So there are significant opportunities for energy savings and emissions reductions by optimizing the fuel-to-air ratio and resulting excess oxygen in the flue gas. Reducing process variation and running closer to constraints is critical for energy improvement. It's common for operators to set comfortable buffers for excess oxygen to heaters to ensure safe operation, but it's not energy efficient. So the chart on this slide demonstrates the operational challenges in optimizing the set point for the percent oxygen in the flue gas of the furnace. With insufficient oxygen, one runs a safety risk with possible shutdown of the furnace or boiler and also emissions issues. With excess oxygen, there's a waste of energy and possible permitting issues. So in the upcoming slides, we're going to discuss the option of safely targeting a lower percent oxygen set point by investing in fuel gas or natural gas measurement and control improvements. So Emerson offers a really holistic optimization solution for fired heaters, which is called Smart Process Heater, which is a BTU-based combustion control system that incorporates advanced measurement and analytical systems along with optimization and control software. But in this presentation, we are really going to focus on the measurement side of things and really the measurement side of that optimization solution. And one of the measurement devices, which is pretty essential to any fired heater, is the flue gas analyzer. With Rosemount's flue gas analyzer, you can obtain accurate and dependable analyses to look at the combustion efficiency continuously. And these in-situ oxygen and combustibles detectors can help to effectively monitor these components in the flue gas for feedback control. There are also opportunities to look at the front end of the combustion system, at the fuel gas or the natural gas as it's being fed into the heater or the boiler, and reduce the impact of the variability in the fuel. With micromotion Coriolis meters measuring natural gas or fuel gas rates in mass, the impact of composition changes is greatly reduced, as we're going to show you. Additionally, micromotion offers a specific gravity meter that can also be used at the fuel gas header to infer the energy content and incorporate that energy content into the control scheme, allowing operation closer to the ideal fuel-to-air ratio. Being able to reduce the excess oxygen pays off quickly, as you can see in the bar. In fact, just a 1% reduction of excess oxygen can be worth as much as $750,000 per year in a 250,000 barrel a day refinery. Again, getting back to that project viability question and how you can really justify these improvements to the combustion system. So this next slide demonstrates how mass measurement of the natural gas or the fuel gas reduces the variability in the heat content. The table on the left shows two very different compositions for fuel gas, but what one might really expect from a typical refinery. One of the fuel gases has 50% hydrogen and 46% methane, and in the other case, it only has 25% hydrogen and 67% methane. So for these very different cases, the variation from the average heat content would be only about 3.8% on a mass basis, as compared to the variation from the average heat content on a volume basis, which would be 14.5%, almost 4 times as much variation. Now, I've also looked at a lot of different analyses like this in the fuel gas at various different refineries, and I've seen a lot of variation, even much greater than this, on a volume basis. So there's a big benefit. The same principle applies to natural gas, only the variations are a lot less. So if we look at two sources of natural gas, Amarillo and Ekofisk, we see that on a mass basis, the variation in the energy content is only 0.17%, while the variation in the energy content on a volume basis is 3.43%. So this is more than 20 times the variation with natural gas. So the bottom line is that if you have varying gas compositions of your fuel gas or your natural gas, you can significantly reduce the impact of the variation by controlling the rates on a mass basis instead of a standard volume basis. The one caveat to this is if there is variation in the inerts or non-combustibles in the fuel gas. If most of the variation in the fuel gas is due to non-combustibles, a mass-based fuel gas measurement won't offer much control improvement, and really a more complex solution is warranted. So let's take a look at the control scheme for, in this case, a natural draft heater. Combustion control seeks to provide steady heat output, controlling the outlet temperature, while maintaining emission standards. This is especially difficult with variable fuel quality. Fuel quality changes for a lot of different reasons. You could be using different sources of natural gas or variations in fuel gas composition, which are often caused by changes in the hydrogen content. Fuel flow is typically measured with DP orifice meters, so it's volumetric flow, and the measurement is heavily impacted by density changes, which of course is really the main problem. So some DP orifice meters are compensated for density changes, but many are not. And fuel stream quality is typically measured with a GC in the laboratory and samples taken at lengthy intervals. No one, of course, is surprised that the fuel quality can and will change frequently, but will operate with sufficient margin on the combustion air to accommodate these variations. Even though this is a suboptimal way of operating, excess combustion air provides a comfort buffer. And this comfort buffer comes at a cost, though: reduced energy efficiency and even process upsets from rapid changes in the fuel quality. So the first thing to do to improve fired heater or boiler efficiency, as shown on this slide, is to ensure that you're controlling fired heaters and boilers on a mass basis instead of a volumetric basis. Simply moving from a volumetric-based heating value to a mass-based heating value can reduce control variability by 20 times, as we demonstrated in the previous slide. In fact, due to the reasons we just discussed, the API is now recommending mass-based fuel measurement on fuel gas to furnaces in their recommended practice document, RP556. The intention is to increase the safety of furnace operation by reducing unplanned shutdowns and restart risks associated with fuel gas composition changes. Even though we've established that direct mass measurement at the unit is ideal, there are other ways to reduce the impact of varying fuel gas or natural gas compositions. If multiple fired heaters are operated from a common header, the micromotion-specific gravity meter can be used to get an inferred value for the heat content of that gas. In this way, the energy content of the gas can be measured continuously and fed into the control schemes for multiple heaters and boilers. In some cases, people are using gas chromatographs in a similar way. The advantages of using the specific gravity meter include lower maintenance than a typical GC and response time in seconds instead of minutes. This device measures the specific gravity of the gas without the need to compensate for pressure, temperature, or gas compressibility. The specific gravity value can be used to determine heating value in the case of natural gas, which is then used with the volumetric or mass flow rate at the fired unit to determine the energy input. The SGM works well for most applications, but the one caveat is that, again, the inert content should be steady with less than about a plus or minus 2% variation. If you have highly variable inert content, which is somewhat uncommon, the inferred energy can be incorrect since the energy is inferred based on a specific gravity instead of being measured directly. Of course, you can use the specific gravity meter along with a micromotion Coriolis meter to get the best of both worlds. This will reduce the variability in both the energy and the flow variability for combustion control. As you can see, the SGM would be used with its built-in AGA5-based calculations to determine the inferred mass value for natural gas. It is more challenging for refinery fuel gas, and a custom-built curve would need to be applied for each case if it was established that there is indeed an acceptable correlation between the specific gravity and the heat content. And in most of the cases we've looked at, there indeed is a very strong correlation. So then the mass flow rate can be multiplied by the mass heating value to give energy flow rates. And this is a great approach when you have specific heaters or boilers whose design warrants this approach, as is in the case with some balanced draft furnaces. This approach also makes sense if you have a complex fuel gas system or an extreme fuel gas variations where it's been determined that mass flow alone won't be an effective approach. So although we've talked so far primarily about the efficiency and the safety aspects of improved combustion control, it's important also to discuss how combustion control is directly related to emissions reporting. All around the world, there are measures being put in place to minimize emissions, from reporting requirements to full emissions trading systems with cap and trade allowances. The requirements are stringent and they vary from location to location. Some of the regulatory requirements and emissions trading systems are listed here on this slide. There are many different ways to report emissions, and the rules vary depending upon where you are located and what regulatory systems in place. Some people use continuous emissions monitoring systems, CEMS, for measuring and reporting their emissions. Another commonly used approach is to measure the consumption of the fuel or natural gas and calculate the emissions for reporting. If you're implementing the solution we just discussed of mass measurement of your fuel gas or natural gas, these meters can also be used to report your fuel consumption and calculate the associated emissions. The meters have a very large turndown capability and great accuracy, which exceeds the current regulations. They also have built-in diagnostics that can be used in many cases in place of removing meters for calibration to ensure that they're still performing within specification. So when emissions reporting is based on fuel consumption, the accuracy requirement is typically fairly low. It's usually only 1 to 5% accuracy. So you're wondering, why would you need such an accurate meter? However, it's very important to be able to prove that the meter is performing within the tolerance. And if the system accuracy goes outside of the tolerance, companies can lose their free allowances and cap and trade programs. In larger companies, these free allowances can be worth millions of dollars a year, and the risk of losing those free allowances mean that everything possible is done to keep from risking measurement that is close to the accuracy threshold. So for traditional orifice plates, many regulatory agencies require removing the orifice plates from the line, generally every 1 to 3 years, and taking photos of the plate and keeping those records sometimes as long as 10 years. This is a manually intense process. It's usually performed during a turnaround or a shutdown of the process in what can be a rather intense and chaotic period during a turnaround. This process is greatly simplified if you're using Coriolis meters for fuel measurement. Many regulatory agencies will allow the use of micromotion smart meter verification to take the place of physically removing the meter for checking or calibrating it. Typically, the regulatory body will accept manufacturers' recommendations for verifying the health and the performance of the meter. And in the Resource Center on your dashboard, there are letters that have been specifically written for the EU ETS and for the EPA CFR 40 Part 98 that can be downloaded and used for this purpose. So at this point, we'd like to ask for a little more interaction by you. And so we'd have a question to get an idea of how many of you are, how you're really reporting your emissions. So the question is, do you report emissions by measuring the fuel gas or the natural gas consumption? So the answers are yes or no or partly. So in other words, you're doing part by measuring the fuel consumption and then part with a SEM system. You aren't doing it today, but you plan to, or you don't know. So if you could please respond to one of these options, and then we'll review to see what you've said. In most of the refineries and chemical plants that we've visited, they are using a combination of approaches. So we'll see if that is reflected in the numbers that are coming up. It's continuing to grow here. So it looks like a lot of people do it, actually. It looks like we can go back to the live view. So yes, it looks like most people do report their emissions based on fuel consumption, 40% of you. And there aren't very many that actually do not use the measurement at all. And then another good portion of you at least partly use SEMS and then partly use the fuel measurement. So that is again very consistent with what we have found in our interviews of our customers. So, and now what I'd like to do is I would like to turn it back over to Tanya, and she's going to talk about some specific product features and some additional energy management measurement solutions.
Thank you, Julie. Great information, and I like those survey results. It's always interesting to see that. We did have one question come in while you were talking, so I'm going to go ahead and address that, and then I'll kick into kind of some of our product information and giving some more examples. But the question that came in is which micromotion meters and transmitters are capable of measuring gas density? And that's a very good question because we have excellent liquid density meters in all of our Coriolis meters, and we do concentration measurements and different things like that. However, the challenge with gas is that it's much lighter, and so our resolution for density is not typically used out of the Coriolis meters, so like the Elite, F Series, R Series, T Series, that sort of thing. However, the meters that Julie mentioned, the specific gravity meter, is specifically designed for gas to measure density and specific gravity. We also have something called a gas density meter that measures line condition gas density as well. So really the products that we use for density measurement on gas are specific gravity meter and gas density meter, but the Coriolis meters can measure the mass directly and then infer that energy content like we were talking about earlier with Julie. So great question, and we'll continue to answer questions probably toward the end here. So if you are reporting emissions by measuring fuel gas, and it looks like a lot of you are, or you're planning to do this in the future, the Micromotion Elite mass flow meters are really an excellent choice for this. As Julie discussed, the direct mass measurement can reduce the impact of variations in your fuel consumption, which results in energy efficient improvements and a reduction in the excess oxygen requirements. The micromotion meters offer superior turn-down capabilities, and so these are especially helpful when you're feeding multiple units and rates can vary due to online versus offline heaters or boilers. The mass flow accuracy can't be beat. It's best in the world and gives an extra comfort margin for those greenhouse gas reporting requirements to prevent the risk of losing free allowances. The smart meter verification option allows you to check the meter in minutes without interrupting the measurement at all or exposing personnel to the process. With a convenient printout, then gas greenhouse gas reporting really is a breeze, and it's easy to keep track of those records and turn them in and comply with your reporting requirements. For low flow applications, we have new diagnostics that help to ensure the best performance is achieved by checking the zero of the meter using a proprietary set of diagnostics and test conditions. Our latest transmitter, the Model 5700, also provides automatic data logging so you can capture any kind of process upsets and analyze them later. The key takeaway here really is that micromotion meters offer superior performance under real-world operating conditions with minimal interaction and with world-class diagnostic capabilities. If you need any more information on that, you always are welcome to hit that Contact Me widget and we'll follow up with you. But it's not just Julie and I saying that these meters work really well. I wanted to share some success stories that we have. And the first example is about energy efficiency. This customer needed to produce steam for an LCD production process. In order to produce the steam, they were using multiple boilers and burning natural gas. They needed to have really accurate control of their natural gas in their air to make the boiler as energy efficient as possible and to keep emissions to a minimum. Their existing gas flow meters used fixed pressure, temperature, and compressibility, or PTV compensation, which resulted in some inconsistent steam production. This, of course, caused some issues downstream, and they were also spending about $100 million per year for energy, and obviously wanted to reduce those costs if possible, but they still needed to comply with greenhouse gas regulations. So remember from our earlier discussion that combustion with excess fuel can be dangerous and can cause some safety shutdowns. However, if there's too much air or oxygen, the efficiency decreases significantly, increasing your energy costs as well. So the customer chose to implement a 3-inch micromotion elite sensor with a 2-wire transmitter to replace their existing gas meter. They chose 2-wire just so that they wouldn't have to use additional cables and put extra power wiring in there for the application. The elite meter was able to provide accurate natural gas feed rate control without the need for pressure, temperature, and compressibility compensation. And the customer was able to save 10% of their natural gas consumption by improving the boiler efficiency, which ultimately reduced their operating costs by $1.2 million per year. This means that the Coriolis meter was paid for in just 1 week. So how's that for addressing that viability question? They also benefited from lower maintenance, more consistent steam production for downstream processes, and they were able to meet all of their greenhouse gas regulations and reporting requirements. For more information, you can download this actual proven result and read it. It's in your resource center on the dashboard. A number of our refinery customers are also using the micromotion specific gravity meter for gas to identify sudden changes in the refinery fuel gas composition. For this customer, the rate of change in the hydrogen concentration in the refinery fuel gas was really fast, and so they were concerned about lag times between analyzing that composition change and notifying operations of the change. Although a process chromatograph was considered, they had concerns about the sample loop and analysis lag times. They were worried about the capital cost and the added cost of maintaining this type of analyzer. They ended up installing a micromotion gas specific gravity meter and calibrated it with hydrogen and pure methane and utilized the specific gravity output as an inferred change in heat value of the refinery fuel gas. The results that they saw, they were able to reduce their furnace trips, lower emissions, and improve efficiency due to improved fuel-to-air ratio controlled to the furnace. They didn't incur the extra costs associated with using a GC, including the higher capital installation and maintenance costs. And prior to the installation of the specific gravity meter, the wide swings in heating value was also causing operations to frequently open and close the control valves on several fired units. This contributed to even more pressure swings in the fuel gas delivery system, and added to the problem of control during these large changes in heating value. For more information about this story, you can also download this proven result from your resource center. As I mentioned in the agenda, we're also going to talk a little bit about managing your steam system. So having a good idea of where your steam is going can help you better allocate actual utility costs and can reduce waste as you gain visibility to failed steam traps and eliminate potential leak points in your steam system. In most plants, steam is produced on-site using multiple boilers and then distributed to various process units using an overall steam distribution system. The number of flow measurement points in the systems can vary dramatically. Some plants allow steam really to just be used by any unit as needed, and then they allocate costs of the utilities based on formulas, and they regulate their supply steam just as much as possible fairly manually. On the other end of the scale, some plants have steam flow meters dedicated to all their boilers and distribution points. This is ideal because it helps to more quickly identify points of high steam usage, potential leaks in the system, inefficient boilers, and other areas where energy is being wasted. It also helps manage your supply based on your usage. The Rosemount 8800 Vortex meter is an ideal meter for measuring steam. The unique Rosemount design is unlike any other Vortex meter and has absolutely no ports or crevices to plug and no gaskets to replace. The all-cast design significantly reduces potential leak points, and when compared to traditional orifice plates, the Vortex meter eliminates the impulse lines that can freeze in colder weather and interrupt measurement. The Model 8800 Vortex meter has the option to have a built-in temperature measurement that can be used for saturated steam, and that way you can directly output a mass flow rate of the steam without the need for a flow computer or any additional wiring. The unique Rosemount design allows the sensor or the thermocouple to be replaced without removing the sensor body or exposing the process fluid. The Vortex meter also has a meter verification option that allows you to check the health of the meter without shutting down the process. For more information, feel free to hit that Contact Me widget and let us know that you want information on Vortex meters. I want to share a little bit about how one petrochemical plant improved their steam distribution network using the Vortex meters from Rosemount. They had 9 thermal boilers that they used to produce superheated steam for the plant. The steam was distributed using 3.5 kilometers of steam piping. Steam was important to the plant because their end product quality relied on constant steam pressures in the distribution system. They were originally using 3 orifice meters to try to manage the network. These meters had issues with leaks and were consuming about 300 hours of maintenance per year. However, it was easy for the steam meters to fall below other more important projects for the plant, so they really needed to be able to prove a strong return on investment to get funding. This is again talking about that viability aspect that we discussed early on, and it looks like some of you definitely struggle with that justification of these projects. So they ended up choosing the Rosemount 8800D Vortex meters with the integral temperature sensor option, and they added pressure transmitters and a flow computer so that they could output mass flow of the superheated steam. They immediately noticed significant reduction in maintenance because leaks were eliminated, and it resulted in a 3% steam system efficiency improvement and saved them more than 200,000 euros per year in fuel. The return on investment indeed proved worthwhile, and the project paid for itself in less than a month. So feel free to download that success story to get more detail, and it is also in your resource center on the dashboard. Another area that gets commonly overlooked in a utility system from an efficiency point of view are the steam traps. Steam traps that aren't properly maintained can often have leaks that go undetected and are a direct waste of energy. Manual inspections are expensive and time-consuming, so they usually aren't done as frequently as they might need to be. Fortunately, Rosemount offers an acoustic transmitter that can detect steam trap failures. We also have an online energy savings calculator that helps estimate potential energy savings and helps you prioritize the steam traps that could save you the most. It also calculates your inspection savings. If you're interested in using this calculator to help you prove the viability of a project, there's a link to it called Steam Trap Monitoring Energy Savings Calculator in the resource box on your dashboard. The Rosemount 708 wireless acoustic transmitter is fast and easy to install and immediately provides real-time visibility to steam traps, indicating any failed steam traps. Armed with this information about your steam traps, it's easy to prioritize and take actions to improve the problematic traps and reduce fuel costs from wasted steam. The device really is a set and forget instrument that's non-intrusive, and if you want more information about this, we have the product data sheet for it in the Resource Center on your dashboard. We've talked about a lot of different opportunities for improving energy efficiency today, and there are even more that we haven't had a chance to discuss. So in the Resource Center on your dashboard, there's a link to something we call the Energy Schematic, and it helps you identify some additional opportunities that we didn't address during this webinar. But let's go ahead and wrap up the webinar information for now. And I just want to remind you that Emerson, if we are your measurement partner, then we can definitely help you improve your energy systems to operate more efficiently, reduce your costs and emissions, and all the while helping to ensure safety and compliance. We have best-in-class measurement devices and a vast amount of field experience that we can use together to really make a difference for you. So with that, I'd like to say thank you very much for attending this webinar. We're going to have time for a few questions now. We do know that there's maybe not going to be enough time for all of the questions, so if we don't answer your question, we will definitely follow up with you offline. You can also use our contact form, again, to request a follow-up visit from a local sales rep. And you are welcome to email Julie or myself directly. So at this time, I'm going to go ahead and turn it over to Allison, and she'll lead us in the Q&A session.
Thanks so much, Tanya, and thank you very much to both Tanya and Julie for all this great information. As Tanya mentioned, we're now going to open up for questions. So just as a reminder, you can use the Q&A chat panel on your console to ask questions. And it looks like Tanya and Julie, we've already got several lined up here, so I'll let you guys jump right in.
Okay, thanks, Allison. I saw a question come in right away after Tanya started, and that was what this question says. It says, we are currently using heavy resid as fuel in our furnaces, and due to continuing pressure from the government environmental agencies, we are contemplating to convert our heaters to natural gas firing, which is a huge investment. Can you give some idea of any refinery that has done such a conversion? I personally have not been involved in such a conversion project, but I can definitely check with our various world area flow advisors to see if anyone has been involved in such a project, because I'm sure that this is going on in many parts of the world where they are still, burning heavy resid and heavy fuel oils in the furnaces. So I will check and follow up on that and get back to you.
Okay, it looks like somebody asked if special calibration is required for fuel gas meters, and the answer to that is no. Every micromotion Coriolis meter that goes out of the factory is calibrated on water, and we have done multiple tests and have information to show that the water calibration actually transfers directly for gas applications, and we have further information about that if you want to see that. But basically, once you get it out in the field, it will operate right out of the box at our specified accuracy, so that could be like 0.25% or 0.35% depending on the meter, but there's no special calibration that is required for these to work on the fuel gas applications. Let's see here.
I see another question that came in, Tanya. It says, are vortex flow meters resilient to steam that is not very clean? I'd be worried about shetter bar erosion. I believe that most steam, that is the case with most steam measurement, that it's not very clean. And in the design of our vortex meters, a lot of care has been taken to design around very common problems like this. And so we have different metallurgies that are available, some that are more resistant to erosion than others are, and that is as how we would be able to handle these. We would be able to recommend a vortex shetter bar metallurgy that's appropriate for this particular application.
Okay. Somebody asked about, do users that switch to mass flow measurement on fuel gas stick with volumetric flow measurement on combustion air? And I think that's a really good question. I think it varies a lot, but a lot of people are using, on combustion air, a lot of times it's fairly large line sizes with fairly low pressures and low mass flow rates, and so a good device to use for an application like that might be an Annubar type measurement. And so I think the measurement on the air side, especially since air is pretty easy to convert from volume to mass just with a constant density, a lot of people are sticking with kind of a volumetric type measurement on their air side, but controlling it based off of the mass from the fuel gas. So hopefully that answers that question.
I see another one that came in. It says, what is the status of the Part 75? I assume that Part 75 smart meter verification approval. I assume that might be referring to an EPA. I think what we would need is we might need some more information. Or can you address that, Tanya?
I can address that.
Okay.
So EPA has multiple different people who work on different parts of the Code of Federal Regulations. So while Part 98, definitely we have a lot of customers who have used that for greenhouse gas measurement. For the acid rain part, which is the Part 75, that does not accept smart meter verification yet. We are working to try to get verification methods accepted, but for now they have very specific calibration requirements. If you are doing any of those acid rain things, definitely contact us. We can give you more information about those specific calibration requirements and how we can meet those out of the factory, because there are some special things that you should order for any kind of Part 75 calibration. So, good question.
I see another question that came up. It says, our fuel gas is really dirty. Is there a risk of a Coriolis meter plugging? So our Coriolis meters, because they have very large diameter tubes, and there are no small impulse lines that could plug and really nothing in the flow path, we haven't ever experienced any plugging issues to my knowledge in fuel gas applications. So that's one of the big advantages really of installing a Coriolis meter in fuel gas, is really the lack of maintenance that's required due to any sort of plugging issues that you might have with a different type of device.
Okay. So somebody asked, do the vortex meters detect or compensate for superheating of the steam? And that's an excellent question. So the vortex meter that I mentioned that we have with a built-in temperature measurement, that has steam properties built into it for saturated steam. For superheated steam, you are going to have to take pressure into consideration, and Actually, the success story that I shared with you about that customer who implemented their steam distribution system with Vortex meters, they had superheated steam, and for that application, they did end up using some Rosemount pressure transmitters and bringing that information into a flow computer to calculate the mass of their steam. So with superheated steam, you do have to take pressure into consideration as well, and that can be done through a flow computer. So, great question.
Okay, there's another question that came in. It says, I have heard there is a high pressure drop through Coriolis meters. Is that the case? That's a good question as well. Something that we have dealt with in the Coriolis world for a long time, and the way to answer that is absolutely not. We now have larger size meters, and we can essentially design and use a Coriolis meter. We can size it appropriately so that we can measure accurately the flow, but get a low pressure drop through the meter. So it's essentially you can design it so that you can basically get the same permanent pressure loss as you would with an orifice plate in most cases. So having these large line sizes, especially in refineries and big chemical plants, really helps us to eliminate that issue of having a high pressure drop through the Coriolis meters.
Perfect. Well, thank you so much, Julie and Tanya, for all this great information, for answering all these questions. Again, if you have any additional questions to everybody and all our attendees, please don't hesitate to contact via the button at the bottom of your console, or as Tanya mentioned, feel free to directly email Tanya and Julie, and they'll be more than happy to answer your questions. We thank you so much for joining us today. And again, we will be sending out a link to the recording of the webinar tomorrow via email, along with a list of all the additional resources that you do see on your right side there. We'll also be including that in the email, so you don't have to worry about remembering what those are. And again, that will be sent out tomorrow. So again, thank you again for joining us. And on behalf of our guests, Tanya Wyatt and Julie Valentine, as well as everyone at Emerson Micromotion, we thank you again for joining us and taking the time to view the webinar, and we hope you all have a great day. Thank you again. Bye-bye.